Students, this is a short video on explaining the trig sheet or the green trig sheet. What I've done with my sheet is I've folded it over to where it says trig info sheet at the top. And this sheet actually, you could look at it as a sheet that has four different parts to it. You've got these, the front and back here, then you have inside here, you got those two sides as well. What I want to do on this short video is go through this and try to help you to be more comfortable with this. I want to be able to get you to feel a little bit more at ease about using the sheet. Another thing I need to do is thank Mr. Paul Dawkins who put this together. This is a result of my 20 years of working with trigonometry and this man's many years and trying to gather together one sheet that will help you out. These things are very helpful. I also encourage you to visit the Unit 8 discussion and download this sheet to your computer so you could look at it. I urge you to print it out. You're welcome to print it out. So please keep that in mind. Now, I did make some changes on this sheet as I was talking to people and asking people questions and working with individual students in our class. So I would go back and reprint out what I have. And also, I'd like to urge you not to make any additional notes on this sheet. The reason why is because it's this sheet that I'd like you to be able to use on exam 4. And it's this sheet that I plan to have included on the final exam. So it's important that you don't get distracted by additional information. Plus, I think there's an academic honesty part to this as well. All right, so keep those things in mind, and let's go through the sheet, shall we? Okay, again, there's your front. You can call that page 1, page 2, page 3, page 4. Whatever you want to. We're going to go through all of these items just one piece at a time. All right, let's start off with the following. Okay, so again, you got the front side and then what I call page 1 and then page 2. All right, number 1, definition of trig functions. Now, what we're doing is we're showing you this triangle here with the opposite, adjacent, hypotenuse. Don't forget your shortcut letters. And what we're saying is that we're assuming that each of these angles are greater than 0, less than 90 degrees. That makes sense. And don't forget, sa, ka, toa. There's the 3 right here, and then there's the reciprocal functions right there. So we can call this right triangle trig. All right, and then please be mindful. Then we get a circle with a length of 1 unit, and then we go around and we define triangles. See, notice over here I've got this point, I've got this x and the y there. So remember, sine is just the y, cosine's just the x, and tangent is the y over the x. That is very important. And these guys over here, you should know by now. All right, so those are some basic definitions. Let's talk about what I call facts and properties. If you notice, I'm going through the sheet one section at a time. Okay, so sine, we're talking about domain. Cosine, we're talking about domain. Remember, it can go round one way, round the other way. Tangent, remember, tangent cycles through every pi. Cosecant is like the sine. Secant is like the sine, but they're reciprocal, so please be mindful of that. And then cotangent, again, cotangent, it repeats, right, after every pi. And you don't have a domain value where there's a vertical asymptote. Okay, that makes sense. So that's true for the secant and cosecant. We looked at those graphs. All right, let's take a look at the range. Now we know about sine. Sine goes from 0 to 1, -1, and then it repeats. Same thing for cosine. Remember, tangent has this kind of shape to it, so its range is from -infinity to infinity, and then you have the cosecant, secant, and you may remember what those graphs look like. They look like horseshoes, right? Okay. Let's talk about the period. The period of a function is the amount of degrees that cause it to repeat. So again, the sine, one period, is 360 degrees or 2 pi, and then it repeats. Or if you think about the unit circle, I go around, and then the values repeat again. That is what this is talking about. Also, it talks about this little formula. I used the formula period is equal to 360 over b, or the period is equal to 2 pi over b. And don't forget, I used the little formula y is equal to a sine of b x minus d. Whoops, I'm sorry, x minus c plus d. So that should be familiar to you. Okay, what I did is I reworked a little bit of this particular part of the sheet so that you may be able to see a little bit better. Please be mindful, we have the degrees, we have the radians, and then we have the values. Remember, it's a unit circle, so the radius is 1. There's tricks to remember these numbers over here. This should be pretty clear by now. Also, please make a mental note. All students take calculus. So what does that mean? It means all of them are positive here, sine's positive, everybody else negative, and then tangent, cosine. That's an important part of your sheet. So please be mindful of that. All right, now what I did at the bottom, I just made a little reminder to you that when we're talking about the unit circle, okay, and we have a point on the circle, that the x is the cosine of the angle. All right, so for example, 5 pi over 3, if I have an angle 5 pi over 3, by the way, where is that? That's right here, right? Okay, of course, when we say the angle, we mean from the initial side all the way around here. That's 5 pi over 3. The cosine is the x. Look right here, okay? So the cosine's 1/2 and the sine is negative radical 3 over 2. Now try to remember what I said. You need to know those two special triangles, the 30, 60, 90, and the 45, 45, 90. I've said that repeatedly and showed you videos, so please be mindful of that. Okay, let's take a moment and talk about the inverse trig functions. Now, without a long explanation, remember that the sine went from 1 to -1, but inverse sine goes from 1 to -1, and it's got a certain domain, and that would be from -90 to 90. Okay, remember it has to pass the vertical line test, so that is why we have to limit that domain. So that's enough. That's enough said there. Let me just do this. Let me just draw this another way. The sine, the inverse sine, is defined for positive values from 90 down to 0, and then the negative values, -90 to 0. All right, so the definition, this is the definition of an inverse function. You're just switching the x and the y. So that's really pretty straightforward right there. Next, the domain and the range. So this is what I'm driving at here. For the inverse sine function, which I'm talking about right here, there's a domain, and there's the range. I don't think I said that right. Let me go back there. True, that's true. Okay, that's pi over 2, or 90, and then negative pi over 2. Okay, so even I get confused on that. All right, so we have the inverse cosine, the inverse tangent, domain, and range. Let me just take a second and do the inverse cosine. Okay, remember it went from at 0, it was 1, and then it goes all the way up to pi, and that's -1. Okay, so that's the inverse cosine function. Remember, when you put this in your calculator, you need to be mindful of that. All right, these are just inverse properties. That pretty makes sense, and this is another way of writing that. Okay, the law of sines and the area formulas I'll come back to. That's on that one side, but I'll just mention it now. All right, formulas and identities. So here we go. Let's go through these. I'm just going to zone in on a few here. Okay, these are called the quotient identities. These are the reciprocal identities. The Pythagorean identities. Remember, on the unit circle, x squared plus y squared is equal to 1, okay? And the even-odd formulas. In other words, the sine of 30 degrees is 1/2, but the sine of -30 degrees is -1/2. That's all that's saying. Those are called identities. The periodic formulas, so, obviously the sine of 30, I hate to say this, but I almost feel like I got is 1/2. And the sine of 390, that is 1/2 as well. So it's called the periodical nature. Sum and difference identities. Cannot stress how important these identities are. Extremely important. So what's the sine of A plus B? It would be sine A cosine B plus, okay? And then the minus, just follow that pattern. Double angle formulas. Please be mindful that the cosine has some variance to it, and they are used very, very often. Let's talk about the degrees to radian formula. I drilled this home in my top 10 trig ideas. Remember, pi radians is equal to 180 degrees. Sometimes you got to find the decimal. Sometimes you need to leave it in terms of pi, so please be mindful of what you're doing there. All right, this is one that gets people a little bit, so I'm making a big deal about this. The half angle identity formulas. Now, actually, this part could be called power reducing, but I rewrote them so that you can have this on your exam 4 and your final exam. These are actually better written half angle formulas. And don't forget, everything's in the radicals there. And you have to remember what quadrant you're in so you could pick the right sign. Be mindful of that. All right, the cofunction formulas. Obviously, if I had a right triangle here, this is angle A, this is B, this is blah, 3, 4, 5. Okay, so the cosine of A is equal to the sine of B. Those are called cofunction identities. Now, these special identities that you see, product to sum, in other words, product to sum or difference, product to sum or difference, these are used a lot, and they're derived from the sum and difference formulas. In our class, you had to work problems in your book, but they did not show up on your assignment. So remind me next time. I'll try to include that for the next group of people. But these are very, very important identities. Okay, now I do want to kind of finish up by talking briefly about the law of sines and law of cosines. Again, when I work problems, I just put A, B, C, little a, little b, little c. The law of sines, very helpful. The law of cosines, there's different versions to the law of cosines, and we're not going to use the law of tangents. What I've done is I've reworked the law of cosines, and I do the problems this way. Little p squared is a squared plus b squared, and so forth. So that's very okay. There are two area formulas. That's one related to the law of sines, and this guy actually is called Heron's formula. Okay, very, very helpful. So please watch how I explain that, and that will help you out. I want to thank you for taking a moment looking at this brief video on the green sheet. I hope this helps you out. I have certainly invested a lot of my time into it, and I hope it helps you as well. Best wishes.